Perfect. That's good. What is happening? 403 to the HAZ. Mr. Nelson here with a beautiful, delicious can of bubbly lime flavor today. Okay, pre-Cal 12, how are you? Excuse me. Ooh. So we are into part 3 of our trigonometry super unit. And now we're kind of getting into the denouement, the back end, the last little bit. And that's trigonometry identities. So we have our ratios, sine, cosine, tan. And we also started learning about our reciprocal identities in previous unit. And today we're going to look at those three in combination with the quotient identities, where tan is equal to sine x over cos x. And we get that because we know that any point on our circle is going to be cos x for the x coordinate, sine x for the y coordinate. Just like any point is going to be here with an angle here, and then sine x will be the y coordinate, and cos of that angle, of theta, will be the x coordinate. So the x coordinate is cos of x, or of the angle, cos of theta, and sine of theta. X and theta get kind of interchanged. So tan will obviously be the opposite over the adjacent, or sine over cos. And then cotan, which is 1 over tan of x, is just going to be the inverse of tan of x. So let's talk about these more. The first thing we're going to introduce is the idea that there are such things as non-permissible values with these identities. So let's look at all of them. For cosecant, where is cosecant x going to be undefined? Now remember, non-permissible value is basically any value that's going to make our expression undefined, or 1 divided by 0, undefined. Okay, so in this case, if we have 1 at the top, what is going to make the bottom equal to 0? Well, where is sine of x equal to 0? Sine of x is equal to 0 here and here. So we say that x cannot equal any multiple of pi, because 0 pi is 0, 1 pi is there, 2 pi is back here, 3 pi is back here. So any multiple of pi is going to have a sine of 0, or a sine of x is equal to 0. So we cannot equal pi times n, where n is any number that's an integer. And we have to use integers and not real numbers because integers are whole round numbers that work for us, okay? So if I have x is equal to pi, sine of pi is 0, 1 divided by 0 is undefined. So that's a non-permissible value. Here's a non-permissible value for this guy. How about for secant? Well, where is cos of x going to be equal to 0? Well, cos of x is going to be equal to 0 up here when x is pi over 2. Excuse me. So basically, and that's going to be the case, it's going to be 0 here, and here, and here, and here. So that's going to be x cannot equal pi over 2 plus n times pi. Pi over 2 plus 1 pi is 3 pi, plus 2 pi is 5 pi over 2, okay? And it couldn't be just like up here with pi over 2 times n, because in that case, if n is 2, then we get 2 pi over 2, which is actually pi over here. So it has to be pi over 2 plus n times pi. We're adding a certain amount of pi's each time. And then n is an element of the integers. Here, cotangent, where is tan of x going to be undefined? Or where is tan of x going to be equal to 0? So where is tan of x equal to 0? Well, tan of x is equal to sine of x over cos of x. So where are we going to get a sine of x is equal to 0 and a cos of x is equal to 1, or any other number? sine of x is equal to 0 at any multiple of pi. 1 pi, 2 pi, 3 pi, 4 pi. So tan of x is equal to 0 at x is equal to some multiple of pi. Any places where we have we're on the x-axis. So it can be 2 pi, 3 pi, 4 pi, 5 pi. So that's going to make, and then we're going to have cos of, when x is equal to pi or some multiple of pi, cos is going to equal to 1. So this will be equal to 0 over 1. Okay? And that's important because that means that 1 over 0, over this situation, this is x is equal to 1 over tan of x, when tan of x is equal to 0, will make this undefined. So that means that x cannot equal any value that's going to make tan of x equal to 0. So x cannot equal any multiple of pi, where n is an element of the integers. Okay. So tan of x will be undefined itself. Tan of x goes undefined when sine is 1 and cos is 0. And we get that at pi over 2, any multiple of pi over 2. So x cannot equal pi over 2 plus n pi, where n is an element of the integers. Now this might be take a while to get your head wrapped around. I know that this is full disclosure. This is video number 3 attempting to teach this because it was my first time seeing it in 15 years, and it takes a little bit of time. So just chill. If it's hard, it's fine. It's part of the process. It's supposed to be hard at first. It's math. But if you stick with it, math will become your best friend, and it'll show you the light. Just trust the process. So we kind of had to establish these non-permissible values, because now when we jump into the textbook problems, we're going to kind of draw on what we know about these. So I've kind of helped you out that we kind of went through it. And if you should probably prove these to yourselves, these non-permissible values. And who knows, maybe I'll find something that I did wrong. Okay. Let's just do it. Let's just do it. Let's just do it. Let's just do it. Okay. I'm doing number 1 from the textbook. I'm going to do these in red so that we can see them. Is this good red? That's bad red. Is this good red? That's good red. Okay. Excuse me. Man, I'm burping. Excuse me. Terrible. Okay. I'm going to do 1b. Okay. We've got sine of x over cos of it, or over tan of x. Okay, where is this? What are the non-permissible values? Are there any non-permissible values for sine of x? No. What are the non-permissible values of tan of x? They're right here. So that's the non-permissible values for tan of x, right there. So in this case, we just pull it from here. X cannot equal pi over 2 or anything on the x-axis, plus n pi, where n is an element of the integers. And being the insecure math teacher I am, I go back and I check the answers, because who cares? I am what I am, and that's all that I am. Oh. Okay, yeah, so I did that wrong. My bad. Okay, so the first thing we need to do is we got to look at tan of x itself, okay? And when we look at tan, we know that the non-permissible values are this. So that's one non-permissible value. X cannot equal pi over 2 plus n pi. Okay? Where n is an element of the integers. The other one is there any values that are going to make, well, if I write this out, sine of x divided by sine of x over cos of x, I can rewrite as sine x cos x over sine x. And what is going to make this equal to 0? That is equal to 0 when x is any multiple of pi. So that's going to be equal to 0. X cannot equal pi, any multiple of pi. Okay, so there's one non-permissible, or sorry, the non-permissible just based on tan, and then the other non-permissible based on when we expand this out. And in doing so, we get, well, now we can combine these two, and basically, x cannot be any of these points, which we can rewrite as these two, or we can rewrite as one whole thing where pi over 2, any multiple. So if I have 1 pi, it's pi over 2. 2 is 2 pi over 2, or pi. 3 is 3 pi over 2. 4 is 2 pi. So that's how we can get every point on that end, okay? Now I'm going to do C, and I'm going to leave D for you guys, okay? So these are the NPVs right here, okay? So let's do C. C is cotan of x over 1 minus sine x, okay? So the first thing we do is, well, let's look at the non-permissibles of each individual. And the only one I have to look at is cotan, and these are my non-permissibles, okay? So so x cannot equal n pi. And so it basically cannot be on the x-axis. Otherwise, this is undefined. Right, okay? And now the next one is, well, now what's going to make the base here? What's going to make that equal to 0? Well, 1 minus 1 will make it 0. And what is going to give sine of x is equal to 1 where? Sine of x is equal to 1, a positive 1, right? It can't be negative 1. Because down here, it's negative 1. Down here, it's 0, negative 1. And if it's negative 1, that would be 1 minus negative 1, and we'd get 2. So it can only be this point here. And that is at pi over 2. Or any multiple of pi over 2, or plus 2 pi. So it's going to be pi over 2, x cannot equal pi over 2 plus any multiple of 2 pi. That will bring you back to this point, because it's only on the north point, on the positive x, positive y, or positive y, that's good. So plus 2 pi, so it's any multiple of 2 pi, where n is an element of the integers. So our final non-permissible values for this one are the original, cotan of x, and what makes the denominator. So it's going to be x cannot equal n pi, and x cannot equal pi over 2 plus 2 pi n, where n is an element of the integers. And Insecure Nelson checking his answers. Yeah, so that's right. And I'm gonna do D as well, because I need to do D for myself. Actually, I'll leave D for you guys to try. Okay. Now I'm gonna do number 3, and it says simplify each expression to one of the 3 primary trig functions, sine, cos, or tan. So we're just trying to get down to sine, cos, or tan. So we'll do A. Because we're going to do A. I'm going to do the Pythagorean theorem next. I'm just going to throw that in next. So I'm going to do A here, and then I'm going to do 4. So 3A, we have secant x, sine x, and we want this down. So what's secant x equal to? It's 1 over cos. So I can rewrite this as 1 over cos x times sine x. And then if I multiply this, I get sine x over cos x, which I know is equal to tan x. So I can rewrite that, secant x sine x is equal to tan x. Not so bad. You can do this kind of stuff, right? Just simplifying it down. And I'm going to do one more. Number 4. Simplify the rewrite expression as one of the 3 reciprocal functions, cosecant, secant, or cotangent. So I'm going to do B here. I've got cosecant x, cotangent x, secant x, sine x. So cosecant x is 1 over sine x. I mean, so I have no idea how to solve this one. I'm just going to start playing around. It's a puzzle. You got to fail forward, and maybe I'll get lucky, but we'll see. So I'm going to just start playing around, because I'm trying to get this down to one of these 3. So cotangent, I'm going to write it as this. So I'm going to just bring them all the way down to their base. That's the strategy. Bring them down to their basic trig functions. 1 over sine x. Cotangent is cos x over sine x. Secant is 1 over cos x, and then we got sine x. And I'm just going to now cancel terms. So this can cancel with that can cancel with that, and it looks like I'm left with 1 over sine x, which is cosecant. So just by expanding and simplifying this whole expression, cosecant x, cotangent x, secant x, okay, APG, secant x sine x is equal to cosecant x. Okay, that's where we just did. Basic, okay? So the next video here, we'll just jump quickly into the Pythagorean identities, which are the ones with the squared terms, okay? Mr. Nelson's got to learn that first. Okay, bye!